In this lesson, we're talking about the idea of margin of error, which is the section here. We could talk about an interval that's created where the population percentage is most likely to lie within. So again, we're creating this range or confidence interval with the margin of error by just adding and subtracting the margin of error. So like for example here, we have this sample here of 20 number of movies used in the original random sample. So there were 20. The estimated probability or proportion was 0.273 or 27.3%, right? So multiplying by 100, but then the margin of error. So again, there's this idea of kind of creating, because data is not truly predictable, like the weather, right? It could go either direction. So by creating this idea of the margin of error, you're creating this interval that the data could fall between. So it's not necessarily the end case, but the majority of it will fall within that data. So based on this margin of error here. So basically, to get this confidence interval, let's say for student A, you are just taking the proportion or percentage, whatever the case may be. You are subtracting the margin of error, and you are adding the margin of error. That's it. So the confidence interval, so here, that our data could fall between is 0.069 from subtracting to 0.477, which is adding. This is the interval. So again, this is not necessarily the lowest or the highest. This is just that estimate using that margin of error. So again, if I wanted to know B, right? B is at 0.205 or 20.5%, however you want to look at it. So again, 0.205. So then here, to create our confidence interval, we're going to subtract the margin of error, 0.189, and add the margin of error, 0.189. So then here we are left with our range, which is 0.016 to 0.394. So again, that is our interval here. So go ahead and just try C real quick on your own. And here we go. So to create that interval, 0.280, all you needed to do was subtract 0.180 and add 0.180, the margin of error. So the confidence interval here for student C is 0.1 to 0.46. So again, here with this first example, I'll give you the chance to read through it. We are talking about the percentage of students who do not support this increase in prices is 82%. However, if I wanted to know and create this interval here that data could fall between, because it's not going to stay at 82% as more data comes in. So we're going to create and use that interval here where the data could end up once all students have been surveyed. And that margin of error is 4%. So this is what we're going to add and subtract. So here, if I've got 82, that means my interval is subtracting 4, which is 78%, and adding 4, which is 86%. So this is the interval that, again, as the data comes in, that our data could fall between. So which of these values or these percentages could be a possible outcome or percentage because it falls in the confidence interval? Well, 74% is below. 77.5% is below. Now, 80.2% is between, and 87 is above. So 80.2% is a possible percentage of students that say that they do not support the increase. So another way of looking at this is, which of the following means would be reasonable based on the estimate of 16 hours with a margin of error of 11. So again, we're just looking for what could be reasonable, again, as we're creating this interval. So subtracting 11 is 5, adding the 11 is 27. So within this interval, which of these is reasonable? Well, 1 is too low, 20 is in between, so let's keep going. 4 is too low, 29 is above. So go ahead and pause the video and try the U-try on your own. And here we go. So here we're looking for which of these is plausible or reasonable. You have an estimate of 28 years. So to create your interval, confidence interval, with your margin of error of 13 years. So this is what you needed to add and subtract. So your range, your interval here was supposed to be from 15 to 41. So this is adding and subtracting your 13. So which of these values falls within that range or that interval? B, 40 years. So just to get a couple more problems in, go ahead and pause the video, try this one. And here we go. So again, you have an estimate. So which of these values is plausible? So 38 miles per hour with a margin of error of 8. So this is 30 to 46. So that's why here, after getting this range, the answer is A. This is what's in between. That's what's plausible or reasonable. Go ahead and pause the video and try this one. And here we go. So the percentage of parents right now that don't support the increase in prices is 73%. But again, data is still coming in. So you have a margin of error of 6%. So this is 67% to 79%. So which of the values falls within this confidence interval? C, 68.4%. So now another way that margin of error can be used, and you see it a lot like during elections, because again, data is always coming in, right? So the data, when you have a percentage at one point, that doesn't mean it's going to stay at that point, hence the margin of error. Now, if there's overlap in the percentages between multiple people, then we cannot make a prediction. But if at one point, based on the margin of error, there is no overlap, then that means you can make a prediction in regards to the winner or what has the most amount here that's going to come out in the end. So here's, for example, we have Smith, who is right now at 55% of the votes, and Thomas is at 45% of the votes right now. Now notice they add up to 100%, so, but that doesn't mean that these are the percentages. So that's why there is right now, with the voting still coming in, a margin of error of 6%. So for Smith right now, yes, is in the lead at 55%. But with that interval, the margin of error, right? It could go either direction. So 49% to 61%. Again, this is just a interval, an idea, an estimate right now. This is not always going to be 49. So then Thomas right now is at 45%. But according to our margin of error, 39% to 51%. So can we predict that Smith is the winner right now? So here's what we mean by that overlap. So Smith is, think about it like a number line, 49 to 61, right? So it's covering all those values, 49 to 61. Then Thomas is 39. Well, 39 is below 49, so I'll kind of draw my number line here. So 39. Now, where is 51? 51 is between 49 and 61. So is there overlap in the data? Yes, from 49 to 51%. So can we project that there is going to be a winner? No. Due to the overlap, we cannot predict right now that Smith is the winner. So go ahead and pause the video and try the two U tries on your own. And here we go. So for the first one, you had 3 people. So right now, Gonzalez was at 38% of the data. 31% was for Chang, so 31%. And Harris was also at 31%. Now, that's their percentages right now, but with a margin of error of 3%. So Gonzalez right now with the margin of error is the range of 35 to 41, right? Subtract and add 3. So here with our 3% margin of error, 28 to 34. Add and subtract 3. So same thing. So now looking at the percentages, was there overlap? So for Gonzalez, 35 to 41. That's the range here, covering those values. So then the others were 28 to 34. So 28 is below 35, so 28. Now where is 34? Well, 34 is also below 35. So is there overlap? No, there is no overlap. So can we project that there is a winner? Yes, we can state that Gonzalez is going to win because now, based on the margin of error, there is no overlap in the data. So then in the next U try here, you have candidate A and candidate B. Now, candidate B right now is leading at 53%. Now, even though we don't have A, do we know what A is? Well, yes, because the percentages will add up to 100. So if candidate B is at 53, then that means candidate A is at 47%. So now here, margin of error of 7%. So A is 40 to 54, and B is at 46 to 60. So let's first see if we can even make a prediction or not. So first off, even though there's a margin of error, this is created so that we can trust the data. So C is not the answer. So now here, let's see if we can make a prediction. So 46 to 60 is 1. So 46 to 60, 40 to 54. So 40 is below, but 54 is between here. So is there overlap? Can we make a prediction? No. Candidate B cannot be predicted because the percentage of voters is between the 46 and 60. So we cannot make a prediction. So again, candidate B will not win just because his poll is greater than 50 because of that overlap here. Then technically candidate B could possibly get more than 60. This is just to show if we can make a prediction. So that's why here the answer is B. So then the last U try. Here we've got 44% is going to vote for Tom Brown. So TB, he's going to get right now at 44% with an error margin of error of 4%. So here the range is 40 to 48. So this is the confidence interval. So again, Tom Brown right now is at 44%, but could also go down and lose from 40 to 48. So in order to win, a candidate must have 50% or more of the total votes. Can we determine? So again, if Tom Brown, and then there's another candidate, right? So let's say it's candidate C. Well, if Tom Brown's at 44%, then that means candidate C is at 56% with a margin of error of 4, which is 52 to 60. So is there overlap? No. So can we state if there's going to be a winner? Yes, but unfortunately, Tom Brown is going to lose because of the lack of overlap here between our two percentages, and Tom Brown is less than and under that percentage.